Any questions, please go ahead. If you have any questions, go ahead and ask the questions in the chat. We're going over domain and range right now. And domain and range is just your X and your Y values. Okay, what X values are allowed to use and what Y values we get from it. The example is, let's say domain is the hours I work and the range is how much I make. So the domain is when do you work? I work between the hours of 8 and 3 every day. And Y is how much I make. Maybe it's between 0 and let's say $300. So every hour I work relates to some type of range value. If I work 0 hours at 8 o'clock, I haven't made any money. But by the time I work till, let's say, 3 o'clock in the afternoon, I've made 300. Will the range ever be negative? No, I'm not going to lose money when I go to work. And will it be above 300? Nope, because we said that's my maximum range. How about my domain? Will I work at 4, 5, or 6? Nope, that's not in my domain. Okay. So for this problem, the question is, what X values are we allowed to use? Sorry. What X values are we allowed to use? And one thing that we learned is that logs solve for exponents. Okay, logs solve for exponents. And if I want to rewrite this, this is 10 to the y power is equal to x minus 2. Remember my circle of logs type of problem? We can go this way. 10 to the y power is equal to x minus 2. Now, if you look at x here, sorry, not x, the 10 to the y power, will that ever be negative? Will this ever even be 0? Can I say 10 times 10 times 10 times, a bunch of 10s? This gives me 0. Will this ever happen? No, it just keeps getting bigger. It could get smaller. It could get smaller if I wrote, for instance, the square root of 10, which is 10 to the 1/2 exponent. So this could get smaller. The square root of 10 is, for instance, we know the square root of 9 is 3, and we know the square root of 16 is 4. So the square root of 10 is 3 point something, which is less than 10. So we could get smaller, but we can't ever get to 0. So one thing that we realize is that this number here can't make the answer become 0 because we can't even reach 0. We also can't be negative at all. So what number would make this go to 0? X plus, no, sorry, not plus 2. X minus 2 can't be 0 because we can't, at least I didn't say ain't. Log base 10 of 0, darn it, I wrote 10, does not exist. And once we hit 0, that's when we start to approach all the negative numbers, -1, -2. And we said if we can't hit 0 and we can't be -1, we can't -2. Well, what values can we use? We can anything on the right. So what numbers can we use? We can't use 2, but we can use 2.1. Okay. 2.2. Okay. 3 is okay because all those numbers will be greater than 0. So our domain for x can be, some people write it this way, where x is greater than 2. This is the variable you're talking about, and this is the condition. Anybody have a question about domain? Okay, if you want, you can raise your hand. I can see it when you raise your hand. Okay. All right. The next part is, what's the range then? Well, if you just graph it, actually, the log graphs look like this. That's what logs look like. And one reason why is because they are the inverse of exponents. And they're supposed to reflect themselves over what we call x equals to y. Okay? They're perpendicular. So if you look at my basic graph here, this is, let's say log y is equal to log of x. X can't be 0. We said log can't be 0, so we don't cross that boundary. Log can't be negative, so x can't be negative either. But if you notice the y values could be anything, because log can solve for exponents. Log solve for exponents. And log can be, the answer could be -1, it could be 0, it could be +1. It could go all the way to infinity, go all the way to -infinity. And that's our range. So just by looking at the graph, we see that, hey, y can be anything we want. Even for this log that we drew, so we talked about it right here. So y equals to log base 10 of x minus 2. The way we talk about the graph is, what values can we not be? Well, I can't be 0, so x can't be 2. X for sure can't be 2. And x can't be any negative numbers. So anything less than 2, x, darn it, I wrote the wrong thing up down here. I don't know why I wrote greater. X, right here, I made a mistake. Okay, I made a mistake there. That goes the other way. X is less than 2, I'm sorry. So x is less than 2. If I put 2, we're equal to 0. If I put 1, we're negative. If I put 0, we're negative. If I put -1, we're negative inside the log. So we can't have any of these numbers, because logs can't be negative. So the graph has in a sense, a vertical asymptote at 2. What log do we know the answer of? One of our basic ones that we talked about before is log 10 to what exponent is 1? Log to what exponent is 1? 10 to what exponent is 1? Well, 10 to the 0 power is 1. So if we say x is 1, what is y going to be? If x is 1, y is 0. Okay. Now, for this problem, how can I make this problem here equal to 1? What minus 2 is 1? What minus 2 is 1? How about 3? Isn't 3 minus 2, isn't that 1? Which gives us our log of 1. So at 3, our y value is 0. 1, 2, 3. And that's 3 here. Thank you, Giselle. Here we go. And the graph looks like this. Since it's a multiple choice, you want to look for the easiest points that you're graphing. And that point there, finding your root, finding your 0, finding when the exponent is 0 is our fastest way to graph this. Yes, I made a mistake back here. I said x has to be greater than 2. Oh, shoot. Darn it. I did write it correctly. I erased it. I messed it up. Yeah. This was the values that it could be. Oh, my goodness. X has to be greater than 2. It's not that x, I was thinking that x couldn't be greater than 2. X has to be greater than 2. These are all the values we are okay with. We're okay with x being greater than 2. And 3 is greater than 2, so we're okay with it. Because if 3 was greater than 2, log would be a positive number. And that's what you wanted. I had it right originally. Why did I subtract 2 from 3? Yes, if you look at this corner here, I need that to become an easy log I know. And one of the there are actually a couple logs that we know for sure. If I say log of 1, that's always going to be 0. Because whatever this number to the 0 power will always give you 1. X, let's not use X, let's say A to the 0 power will always equal to 1 regardless of what your base is. Another one that we know is log base A of A. What power gives it itself? It's 1. So those are 2 ones that we know. Those are the easiest ones to solve for. And just FYI, remember log base A of 0, remember that doesn't exist. No solution. You can't take an exponent that makes something go to 0. So over here, when we wrote log base 10 of x minus 3 or minus 2, we asked, hey, how could I get this to become log base 10 of 1? What x value could I use to plug that in to get into 1? And we said 3 minus 2 is 1. And we know what that answer is. The answer is 0. Does that make sense? The reason why I plugged in 3 was because the goal is to get 1, because I know what 1 is. I don't know anything else. If I plugged in 2, 10 to what power is 2? I don't know. 10 to what power is 2? Hell if I know. That's some decimal. Thank you for asking that question. Okay, so that's one of the easiest ways for us to graph. Let me give you another one. Let's go do another quick graph problem. This also has to do with domain and range, but the domain and range help us talk about the graph. So log, let's say x plus 4, and then we'll say plus 1, and that's our graph. So what value can we not use here? That's one of the first things we want to talk about. What values am I not allowed to use there? We can't have, thank you, Giselle, -4, because -4 plus 4 is 0, and we can't have log equal to 0. Again, log of 0, whatever you have, let's say this is 10, 10 to what exponent is 0? Nothing. Nothing. Okay? Like, what are you guys learning now? Nothing. Sorry. So x can't be -4. And that's the star when everything goes south. 1, 2, 3, 4, dot, 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 right? Okay. So we know the graph does not exist here. So the graph is on the right side. Now, one easy way of finding this is, hey, what value would make log become log of 1? What number would go here that would give us a 1, log of 1? And you guys know how to do this. It's very easy. It's 5, right? 5 minus 5? Nope, not 5. -3? Hey, if I wrote -3 here, isn't 3 plus 4 equal to 1? Hey, we know what the log of 1 is. Log of 1 is 0. So to state that out, if x was -3, would have a log of -3 plus 4, and log of -3 plus 4 is 1, and then we should be here. But there is a slight change here. Oops. No, whatever. If you see here, don't we have to add 1 to it? So if I plus 1, we said the log of 1 is 0. 0 plus 1 takes us back up to 1. So at -3, our y value is actually 1. And this graph slightly changes by moving up by 1. So it's the same graph. We should have been over here, but we got moved up by 1 because of that plus 1. So if I was drawing this graph, if I was trying to do this quickly, y is equal to log base x plus 4 plus 1, I would say first, x can't be negative 4. Draw that. 1, 2, 3, 4. Negative 4. Can't pass that line. Okay, let's find our 0. If I plug in negative 3, log of 1 is 0. And then 0 plus 1 is 1. I have 2 points. You could, yeah. If you want to do another easy point, since this is a common log means base 10. That's going to go pretty quickly. So yeah, this is going to go this way. Find the 0 for the y. That's the idea. And then don't forget to add 1 to that afterwards because we raised it up by 1 space. Any questions here? We're going to go and do exponentials real quick. The example I had up here was 3 to the x plus 1. Y is equal to 3 to the x plus 1. So one way you could do this, you could just start plugging in numbers, right? Plug in 0, plug in 1, plug in 2, plug in 3. 3 to the 0 plus 1 is 3. 3 to the 1 plus 1 is 9, because 3 to squared is 9. 3 to the 2 plus 1 is 3, which is 27. You could do this. That'll give you a great graph. At 0, we're at 3. And at 1, we're at 9. And at 2, we're at 27. If I plug in negative 1/2, what does, sorry, not negative 1/2. What does it look like at negative 1? 3 to negative 1 plus 1 is 0. So 3 to the 0 is 1. And negative 2. 3 to the negative 2 plus 1 is 3 to the negative 1, which is 1/3. What it looks like. So in what type of equation would there only be a restriction on the y? That's what we're looking at right now, this exponential. If you look at this graph here, are we playing anywhere on the bottom? See, there's no negative values, and that's where a restriction from the y comes in. Again, every graph has its own restrictions. Even parabolas have their own restrictions. If you guys remember a parabola, let's say it's y is equal to x minus 3 squared plus 2. The vertex was 3, 2. 1, 2, 3, up 2. The domain and range for this guy, you could be any x value you want. This graph keeps on going forever. But the range was specifically starting from 2. That's where your graph started. So the range here was y's could only be y is greater than 2. Sorry, the domain back here for our last problem, when we first talked about it, we said the domain is x could be greater than 2. And our range, we never formalized it. The range, since we could go anywhere we want, the range was y could be, y is all real numbers. You can just do that as a double R. Or we can write it as a negative infinity to positive infinity. That's also another way of writing it. Sorry, I should get rid of that. Okay, you can write this in here instead. Our parabola here, yes, our range is y is greater than 2. Let's go back to our exponential. You can see that our lowest value is 0, and we don't even touch 0. We're not even allowed to touch 0. I made one mistake here on the range, on the parabola. We are able to touch 0. So I had to include that. I had to include this little mark here because 2 was included in that. So our domain, the domain, and range. The domain is x can be all real values, double R. That's what it looks like, double R. It's like Team Rocket or something. You're into Pokemon. And our range is y, specifically y has to be greater than 0. Am I allowed to touch 0? In this case, no. So it's not included. The exponential controls the range, and the parentheses controls the domain. For that is for logs, I think. Wait, the exponential controls, exponent controls the range, and the parentheses controls the domain. Try to understand your question, Giselle. Is it so exponents control the range and parentheses control the domain? Going to the left, it does become a smaller fraction every time. Yeah, a negative exponent gives you a smaller fraction on a number greater than 1. Why does it not go down to the y-axis? The y-axis is this here. So I think you mean the x-axis. It doesn't go down because, let me rewrite this real quick. Y to the 3, whatever value this is, will this ever equal 0? It'll never equal 0. That's why we never touch the x-axis here. We never touch that. Right, Evan's right. It just keeps becoming a smaller fraction. So it becomes like 1 over 3, 1 over 9, 1 over 27, 1 over 81, 1 over whatever that is, 243. See, that number never gets to 0. It just becomes smaller. Thank you, Evan. Okay. So this graph was shifted though. It shifted 1 space to the left. Why? Because all exponential graphs, y is equal to whatever number, a to the x. Isn't a to the 0 always equal to 1? The graph should have been at 1. But because we did this whole x plus 1 thing is, to become 0, that's actually a minus 1. So this graph got shifted to the left. So if I wrote y is equal to 3 to the x, our values would have been, let's just do the x and y so you guys can compare. 0, 1, 2. 3 to the 0 is 1. 3 to the 1 is 3. And 3 squared is 9. If you look at our, please compare this with this guy up here. At 0, we're at 1, but our old graph was at 3. But at 1, our graph is at 3, our old graph is at 9. And at 2, our graph is at 9, but our old graph was at 27. So the old graph is 1 step ahead of all our values here. And that's what that plus 1 does. It says you're 1 step ahead. And when you're 1 step ahead, it looks like the graph shifted to left. But really means you're 1 step ahead of everyone else. So just as a side note, the way you can think of this is as life. I'm older than you guys, right? I'm older than you guys by what, like 20 years plus? So I'm experiencing my life I graduated high school. Let's say these are our lives. Okay? I experienced my life, my high school life, right over here, while you're just experiencing it now. So in a sense, it's been shifted. Why has it been shifted? Because Mr. Co, E for Edward, X, my plus 20 years. I got 20 years on you. And you're just barely experiencing your life right now. So that plus is a positive because I take your age and add 20 to it. But in reality, it's actually a minus 20. It's a shift in the graph, negative 20 spaces. So which chart do we look at when graphing? The old one? Yes, this is the graph of 3 to the x plus 1. And this is the graph of 3 to the x. And they look really similar to each other, except that's a 3 here, and this is a 1 here. When does this become 3? One step later. Because the 3 to the x plus 1 is one step ahead. So the exponent, the plus 1 or minus 1, let's say, shifts it left and right. Kind of like my age graph here. If I wrote e to the x plus 20, that doesn't push the graph to the right. It actually pushes the graph to the left because it started earlier. And if you want to double check, if I write e to the negative 20 plus 20, that's e to the 0, which is 1. So way back here, that's my 1. And you won't see your e to the 0 till 0. So it got shifted back. So if I write e to the x minus 20, well, a positive 20, that's where this graph would be. And that would be the 1. So whatever happens in the exponent, that shifts it left and right in the domain. And whatever happens afterwards, let's say by plus 5, it's your answer plus 5. Your answer plus 5 spaces up. It's going to be up here. So negative is right and positive is left. Yeah, that's what happens in the exponent. But just remind yourself the reason why your aim is to make it go to 0. And that's the reason why. Okay. So these are the 2 types of graphing examples you guys will have on your practice. You'll have to flip it up and down, left and right. So if I take this graph, let's use this example here, okay? What if I stick a negative in front of it? All my answers are now negative. So all my answers are now negative, going this way. What if I stick a negative in front of this guy? All my answers are now negative. My positive 1 becomes a negative 1. Over here, if I stick a negative, all my answers are now negative, going this way. What about the plus 5 version? It's negative, here, going this way. It's still 5 spaces up. So if you look at our homework questions from before in the book, we demonstrate these. Look at the practice problems on the practice test. You can demonstrate these. Let me pull up one of the practice problems real quick, and we'll see if you guys can figure it out quickly. Oh, it's not. I looked at it. Hello. I'm not posting. There it is. Review sheet number 2. Let's go ahead and view the PDF. Okay. Look, we have a natural log and log problems. Now, let's see if I'm tap on this. Drawing it? No. Let's mark it up. Okay. So first question, is, let's look at the parentheses. This is a log problem. So what number can't logs be? Logs can't be 0. So I don't want this to be 1. So look here. This guy says, A says, I don't want this to be -1, not my graph. I don't want this to be -1, not my graph. I don't want this to be 1. Oh, a possibility. I don't want this to be 1, D. Ooh, a possibility. So automatically we can see what we can or can't have. Next thing, we added 3 to the graph. So it's like your answer plus 3, your answer plus 3. Do you think that's going to raise your graph or drop your graph? If I take your paycheck and I add 3 to it, your page is going to be up. That's this guy here. Thank you, Andrew. Right, rise. So we can solve this problem in less than a minute. Next problem over here, log. What do you think I need to do there? Is it going to move it up or down? Number 3. What number do I have to, I'm not allowed to put there? And up or down. So these log questions can be very fast. And the idea is not having every point right, but understanding what moves what. And all these numbers have an effect. Okay. Looking at number 4, that's an exponential graph. So that's a fraction though. We didn't cover the fractions. Now, I'm going to say something about the fractions. I would rewrite the fractions as 1/2, 4 to the negative x power. Why? Because 1/4 is the same as x to, sorry, not x. Same as 4 to -1 power. And look at all this negative here. If I plug in 1, 2, and 3, don't they all become negative? That means they all become bigger fractions. So it's 1/4, 1/16, 1/64, I think. Yeah, 64. So the numbers are getting smaller as x gets bigger. Getting smaller, yeah. Getting bigger, nope. Getting bigger, nope. So we had talked about this in your notes. If you look back at your notes when we first started exponentials, if it's, let's say, a to the x, this is increasing, but a to negative x, that's decreasing because the graph is getting smaller. Graph is getting bigger, graph is getting smaller. So another value, if I plug in 0, what's anything to the 0 power? 1. And half of 1, 1/2 of 1 is 1/2. Now, which of these look like 1/2 better? If this is 2, this is 1, that's 1/2. That looks pretty good. This is 2, this is 1, and that's a little too small. That looks more like a quarter. So we can probably figure out which one that is. Problems like this, same thing. 5 and 6 exponentials. Maybe I'll change number 6. I don't like the way that looks. I'm going to change right now. Looks too similar to one that we did already. Yeah, we'll change that. I'm re-uploading it right now. Can you go over 5? Sure. 5, what does 2 to the x look like? 2 to the x, 2 to the 1 power is 2. 2 squared is 4. 2 cubed is, so just plug in 1, 2, 3. Plug in 0. 2 to the 0 is 1. So when we just plug in values, we can get a rough idea of what that looks like. Don't be afraid of plugging values in. But we want to practice these so that we can recognize what the graph is doing. Exponential graph, 2 to the x, so it goes this way. And as x gets bigger, so does my graph. Yeah. So not A, not B. Oh, wait. Whoops. A negative in the front makes my graph go down this way, because all the positive values become negative. The more positive you are, the more negative you become. So, oops, dropped my pencil. It could be A. It can't be B. It can't be C. And it could be D. Now, let's plug in the easy value. If we set 2 to the 0, oops, 2 to the 0, negative 3 times 2 to the 0, that's 1. So when x is equal to 0, y has to equal to negative 3. That more looks like 2. This more looks like 3. Yeah, has to be D. Okay. The rest of the problems, like expanding and condensing, that's what you guys did yesterday. Expanding, condensing. Properties, we did that yesterday. Solving for the exponent, right? Get rid of the 5. Then log both sides, then get rid of the 10. Get rid of the 6. Log both sides, and then get rid of the 3.6. Can you do an expansion problem? Sure. Sorry, running a little long on this one. Expanding, where does the 6 go? So it's 6 log base 4 of u to the 6 over v. And if I'm dividing logs, I am subtracting 6 log base 4 of u to the 6 minus log base 4 of v. And we want to move one more space down. U don't belong here because logs bring down exponents again. That's 6 log 4 of u minus log base 4 of v. Now, this is 6 sitting on the outside. We multiply it in. The answer we get is A. Oh, good job, Andrew. You beat me to it. All right. Any other questions? I would just say go through it. Really, it's a lot of stuff that we covered before. You did all these problems in IXL. Down here is pay attention. It says, for instance, fixed annual interest rate compounded continuously. That's P e to the RT, right? Over here, we're 2 times per year. Here's 3 times per year. This is 2 times per year. So be aware that the prompt changes. When's the test? It'll be next week, the beginning of next week, either Monday or Tuesday. I haven't figured that out yet, but Monday or Tuesday. Any other questions? What is the exact formula for 29? Good question. Number 29, since it is paid at 3 times per year, that's A is equal to A naught, or we can call it P. Remember, we call it P also. P, 1 plus R over N to the NT. Okay, I changed that one problem number, I think 6 or something. Remember, I had to rewrite it. So if you could refresh your PDFs, if you guys do have that out, I just changed that one problem. Okay. If there's anything I'm going to add, I'll let you know. I'll put up the, just like yesterday, where you had to plug in the answers, I'll put that up in probably another like 5 minutes. Again, was it easy to plug in those questions? Like I just put slot 1, 2, 3, 4, 5, 6, 7, 9, 10, right? Was it easy for you guys to plug it in? Thumbs up, thumbs down. Yeah, I just changed the PDF right now, that one question, because it was practically the same looking thing. Do you want just the letters, right? This is like multiple choice, just the letters. So please just write the letters. I'll make that clear in the directions. I'll actually change the directions and I'll say, just write the letters. Right. Change it right now. Yeah, just write the letters. That must have been a little confusing. Sorry about that. Okay. Any other questions? Thanks for joining me. Hopefully you guys, I'm gonna unmute you guys now. I'm gonna stop this.